about MQTT in Android. If you're interested in discussing about this later, if you have any questions, you can join the Slack channel, which I have added in my presentation slide. Let's go. Okay, so let's talk about network calls. Does your app make any network calls? Most of your answer would be like, yes, yeah, of course, our app make, because it's very hard to store data in the app. And so you have to make network calls to get data from using the internet. So how do you make network calls? You'd be saying like, I use HTTP, HTTPS most of the time to make network calls. If I ask you, have you used MQTT to make network calls? Your answer would be like, what? What's MQTT? That's what we're going to see. So MQTT is commonly known as the message queuing telemetry transport. It's used as a protocol for IoT, Internet of Things. It's designed as a lightweight messaging protocol. So that means the messages are very lightweight, so it can be easily transmitted without worrying about the bandwidth. It uses the publish and subscribe operation to exchange data between the clients. The key elements we are going to see in MQTT are connect, disconnect, subscribe, unsubscribe, publish, and topic. So while we go through, we'll see what these are. You see that MQTT communicates using something called MQTT message broker. We did say MQTT and HTTP. What's the difference? So if you see MQTT protocol, it actually uses 3 levels of quality of service. We will see what is quality of services compared to HTTP, and that kind of give it privilege of using MQTT, especially for mobile devices. It also has short specification, whereas HTTP specifications are longer, and MQTT messages are smaller in size, so you can be used in low bandwidth. It also saves battery because there's no polling concept in MQTT. The only thing which, when comparing to MQTT, HTTP, there is no enough debugging tools I have found in MQTT. In HTTP, you have Charles Proxy, you have Postman, and you can even use Android Studio's network calls to monitor. But in MQTT, I've only seen is you can use Wireshark and you can monitor the packets, but you cannot have the cool things you can do in Charles Proxy, where you can edit the response, edit the headers, and see what happens. So let's start with talking about, we did see the key elements, right? One of them was subscribe. So what is subscribe? You can see here there's a little topic. Usually there will be a topic and the clients will subscribe to that topic. Here the client can be an Android client, iOS client, or even a web client. So all these clients subscribe to a topic. A topic can be a very simple topic named, you can say as light or HTTP message or anything. The topic is just a simple string. Now let's talk about publishing to a topic. So you see here the topic, a publisher is also a client. A publisher is publishing to a topic. Whoever is subscribed to a topic will receive all those messages. So here the publisher is publishing a message, and we already said that client 1, client 2, client 3 is subscribed to this topic. So they are receiving the messages. How are they receiving the messages? How this communication is happening? That's where MQTT broker comes in place. So the publisher is a client who publishes to a topic a message, and MQTT takes that and transmits to all the clients who are subscribed to the topic. This way, it forms a decoupling so that the publisher doesn't have to know about the end clients. It just publishes and forgets, and MQTT broker takes care of publishing to all the clients which are subscribed to the topic. Let's look at an example. So here, a simple topic is light. So you could see that client 1, client 2, client 3 are subscribed to this topic light, and the publisher is publishing to this topic light a message called on. That means it's saying that light is on, and you can see all the clients are receiving that message. As simple as that. That's how it works. We did talk about quality of service. Let's look at what is quality of services. Quality of service is a key feature in MQTT protocol. Why? Because it gives the client an option to select the level of quality of service based on the application and network reliability. It also manages to retransmit the messages and guarantees delivery. So based on what quality of service you're picking, based on that, it will guarantee a retransmission of your messages. And also it is a very important service that's used in unreliable network to make the communication more easier. Let's see what are the different quality of services are. One is quality of service 0. So what it means is it's just delivers and forgets. Like, here's your message, I'm done. I don't worry whether the client received it or not received it. So you can see here the MQTT client publish a quality of 0 message to MQTT broker. It is also called a fire and forget. So that if you have a network, if you're going on the train and there is not network down and a message is published, there is a possibility you might not get the message. But then there is quality of service 1. What is this is, it makes sure that at least once you get the message. That means you might get the message more than once. Let's see how it works. So here is MQTT client that is publishing a quality of service 1 message, and it doesn't remove the message from the client. It still saves the message until it gets an acknowledgement from the MQTT broker. MQTT broker doesn't wait to send the acknowledgement to transmit the message. It just publishes the message to all the clients who are waiting for it and then sends this acknowledgement. If the MQTT client doesn't get this acknowledgement within a time limit, say for example, 5 seconds is a time limit it has, if it doesn't receive within that time limit, it publishes another quality of service 1 message packet with a dupe message. So dupe message is between the client and the broker, the actual end clients won't receive it. This is quality of service 1. So there is a possibility to get the message more than once. Let's look at quality of service 2. So this is where the message is delivered only once, which is also called the safest and the slowest. Why it's safest and slowest? Let's look at it. So MQTT client publishes a quality of service 2 message. And again, it doesn't delete the message, it holds on to that message. And then MQTT broker also holds on to that message. Even after publishing it to the end clients, it will send an acknowledgement. Once a client receives acknowledgement, the publisher, receives acknowledgement, that's when it deletes a message and sends another acknowledgement. This is when the MQTT broker deletes its message and sends another acknowledgement. So you can see like 4 levels of handshake is happening, like a 2 request and 2 response. And that's why it's called the slowest. But this guarantees at least, only once the user gets the message, not more than once. While looking into after all this, let's talk about all the key elements we said. What are the key elements? The connect, the subscribe, all things. So right now I'm going to explain the MQTT broker, which we are using in our company, which is AWS IoT Core. So I'm going to use AWS IoT Core MQTT concept and talk about how you can connect with it. So let's go to MQTT Connect. So as I said, we are using the AWS IoT Core, supports as a MQTT protocol to transmit message. To integrate in Android, you can use your GitHub SDK available, which is an open source. So you can take it and use it, and even you can add changes to the code. So here in this SDK, it'll have something called AWS IoT Manager. So this is where it implements the broker for the application and also publish and receive messages. So first what you do is you construct the MQTT Manager by passing these values like region, client ID, and account endpoint. So while constructing this MQTT manager, it will automatically set some defaults for the attributes, and we'll also look into what are those attributes are, and you can also control those attributes. You can change the default values from your app. This now establish a persistent connection using the AWS IoT MQTT manager. Let's look into the code of what you need to pass. We did say we have to pass a client ID, the region, and the account endpoint. So what is client ID? Client ID is nothing but any client will have a string of name. So there is different ways of giving it. When I talk about policy in further slides, you'll understand about MQTT client. basically a string which could be between the subscriber and publisher, where it is given in the policy document. So that means you're saying that this client ID is established and it can be used. Next is the region. AWS provides a variety of regions, data centers where you can use. They are US East 1, US West 1. So you can pick those region and you can create an endpoint there. Make sure that AWS account and region are unique. So that means you cannot create an account endpoint with the region US East 1 and expect it for the clients who are in US West 1 with the same account to receive the messages. No, that won't happen. You have to make sure that the account and the region are same. The account endpoint prefix is nothing but the custom specific endpoint which you create in Amazon AWS. There are different ways of establishing a connection. One is using the key store and a port number. So once you go to Amazon AWS and you create a certificate, it will give you some certificate keys. You can use that key store and pass the port number and create them. The other way, you can use AWS credentials provider. After our session, I will show a demo by using an AWS credentials provider using Cognito, Amazon AWS Cognito pool, how we can create an AWS credentials and make the connection. The other way you can do is proxy, and the other one is using custom authorizer. So custom authorizer is a way you can set up. So you will be having a token key name. You have to pass the token and the signature and the authorizer, and the backend, the other client who is going to receive this and process and send back information will authenticate and saying that, okay, you have sent me the right information, and then the connection establishes. Next, so once you connect, these are the different status. We did see the callback, right? So the callback is going to give us our different statuses. One is connecting, the another one is connected, and then reconnecting, connection lost. So connecting means it's saying that once you establish a connection, this is where it is verifying your credentials, your authentication, and saying that and responding back with connected if it's success. If it is not success, we did talk about default. So what it does is by default, it start reconnecting. So that's what the reconnecting information it's giving here, status callback is. And there is a connection error. So connection error happens is, that's when your authentication fails, your token expires, or you're in a network down area and you're trying to connect. Something happens, it actually gives you a connection error. And after that, it starts reconnecting. But unfortunately, in Android SDK, there is no connection error available. It's only available in iOS SDK. So that we will see automatically reconnecting information in it instead of receiving the connection error. And finally, it's done with reconnecting. That means you're saying like reconnect for 10 attempts. After it reconnects for 10 attempts, it will return back you saying connection loss. That means I'm not going to establish any more connection for you. You have to again request a connection request. We did talk about defaults. Here are some of the defaults which will be automatically set. One is auto reconnect. So auto reconnect setting to true, it means that every time you lose a connection, that is when you get a connection error, I'm saying, I want you to reconnect, start reconnecting. And also it has a min reconnect time. That means it's saying like every 4 seconds, try the reconnection and increment it by every multiples of 4 and to the maximum of 64 seconds, and the max reconnect I'm saying is 10 attempts, and the clean session is true. So you can set all these defaults saying that I want to do establish reconnecting. Let's talk about what is clean session. So setting clean session true means it's establishing a non-persistent connection. That means it doesn't store any of your subscription information and doesn't deliver any of the information to the client after it reconnects. When you're setting it to false, it's the opposite, which says it's a persistent connection. Even though it's a persistent connection, it will only deliver the undelivered message if you're using quality of service 1. Let's understand how it works. So you're saying like my clean session flag is true. That means don't save any of my subscription information and your quality of service is 0, 1, doesn't matter, you're already saying it's a clean session. So that means when you reconnect, your message won't be delivered or received. And again, you're saying the clean session is true, even setting quality of service 1 doesn't matter because you're already saying a clean session, so it clears off all your subscription. So no topic or any information will be available. When you're setting it to false, clean session means you're saying that, okay, I will save your subscription information, but if your quality of service is 0 and you lost your connection, it's not going to deliver you the message because quality of service is 0. We already saw it's a fire and forget. So and that time, if you don't receive it, you won't receive it again. But if it's false and your quality of service is 1, then you would receive your information if you lost the connection in between. Let's look into subscribe to a topic. What method you have to call? You just have to call subscribe to topic and you pass the topic. Topic is nothing but a string, and you will mention the quality of service you want to use, and it will give you back a callback. So we did say the quality of service can be Q0, Q1, Q2, but in AWS, it doesn't support quality of service 2. So you have to either use quality of service 0 or 1. Then topic, we did say that topic is a way you get to subscribe and you're listening to the messages in that topic. A topic example could be as much as a simple name as light, or you can say, I'm only waiting for the light status. I don't want to know much information. Or you can think about like this. In devices, my app only supports thermostat and not light. So you can have a topic saying device / thermostat. So you're subscribing only to the topic, you'll be receiving only thermostat information. And there's another application which could subscribe to a topic like device / light, or someone could go to the high level and subscribe to a topic called just device. So they will receive everything, light, thermostats, and other devices as well. And callback will return back once your connection is once your subscribe to topic is successful. Unsubscribe is very simple. Once you establish your connection and you subscribe, when you want to disconnect, you can clean up by calling unsubscribe to topic and removing a topic before you disconnect. Now let's look at to publish to a topic. So for publish to a topic, you call the method called publish string, passing the string. The string can be, it depends on what type of policy it's being set. It could be a JSON string, or it could be just a simple string. And the topic, again, is the same topic we were discussing that you're subscribed to or you want to publish to. And quality of service you said, and you also have a delivery callback and the user data. So this is what it's about. And the delivery callback will give you whether it's a success or failure. And user data it's what is a user data it will be passed based on what you have invoked. Now, we were talking about messages. So we did say that messages can be like a simple message as a string. So that means I'm saying like, just send me a message saying hello, or a message that's saying that today is a good day, or like a string. Then there are called shadow state messages. We are going to look into shadow state messages. This is very specific to AWS. What are shadow state messages? These messages are used to give the device shadow states. That means if a device is created, like an IoT device is created, updated, or deleted, you can use shadow state messages to receive that information. There are kind of two sections in this. One is called decide and one is called reported. So what is decide? Decide is nothing but the device, that is a client, is sending a decide information to the actual device. So here you can see from the phone, I'm sending a decide state. I want the light to turn on, the power to be on, and set the color to red. Then you get the reported state. Reported state is the actual state set on the device. So that means like it says, yes, my light is on, my color is right now red. So that's a reported state. It's giving back to the phone. So we were talking about message payload. you could see that AWS only supports a maximum message limit of 128 KB. So you cannot construct. So if you're working on an IoT space and you have like 10 devices, connected lights, thermostats, and you're saying like, get me all the devices, and it doesn't give you in one single shot. Like in a HTTP call, you can say get devices and you can just get all them in one shot. But here, since it only supports a max of 128 KB, you will be getting like a payload. The payload can be just one device, or the payload could be two devices based on the maximum it could support. So here you can say like, I'm asking get devices, I have like 10 devices. It could be coming as one payload at a time. And since because you're receiving all this as payloads, it's best to have some business logic. Like if you don't know how many devices you're going to get and your UI showing a loading state, when do you want to stop and show all the devices? So you should have a business logic to have the number of payloads and the count you're getting. Let's look at this. So here I'm getting one payload as reported with device one, name and power, and there's another one. So I can be getting like this. So we added a business logic in our app saying that you give me a max count. So who is a publisher, you give me how many devices is there with a max and a count. The count is a num value saying that give me one at a time. So you might think like originally we thought like the num will be coming in order. So that means if the publisher is sending in order as this is the first device, second device. So we had a business logic of saying that if the num reaches max, then we got all the devices. But in MQTT broker, it doesn't work. It's asynchronized. So it's not going to send you in a synchronous order. So here you can see, you can get one payload with a not with the first one which is sent by the publisher, but it is the fourth message. You receive that first, then you might receive a message which was actually originally sent by the publisher as a second message. So you can have a logic of like keeping a counter, and when it reaches the maximum, then means you have received all the payload. Next one is versioning. So what is versioning? This is also is part of the AWS Shadow State support. So versioning is saying that this is the current version of the IoT device that you're receiving it. So here you can say that I'm getting a reported state. So reported means this is what the device is right now in the state. So it's saying that the device is having a power as on and the color is red and the version is 3. So when I am sending a decide state, so I'm saying like change the, probably I'm saying the same value, it should be a little bit different. So I'm saying change the color to blue and the power to off. I can send the same version number. This is acceptable. So your decide state when you're sending should have the same version number as the reported state. If you're sending like below like a wrong version number, that is a below version number. So here I'm sending a version as 2. This will throw you an error saying there is a version conflict. You cannot send this message. Next, another one, as we are talking about version. So if you're receiving, we did talk about it's not, your payloads are not going to come in synchronous order. So here I'm receiving 2 reported states. So first reported state is coming as version 3 and the other reported state, the next reported state is coming as version 2. So this means the second one is an old payload. So you should ignore. So this is not the right value. The current state of your device is color red and power on. It's not blue and power off. So now let's talk about the AWS IoT Core. So if you want to create an MQTT broker in AWS, first thing you need to know about the AWS console, IoT Core, and you can go to manage things and create a thing. So thing is called as the IoT Internet of Thing, where you can create a LifeX or a Philips Hue device and you can manage it. And there is a certificate, and you attach a policy to a certificate. So what is policy and what is certificate? Certificates are nothing but that's what gives access to a specific client to use the policy. So that means if I'm going to use a Cognito user or I'm going to use a different user, I want that user to have access. So that user should be a valid user. Certificate is the only way of saying that this user is valid to access this policy. What is policy then? Policy document defines the privileges. So your what you're allowed to do. As a client, I can allow you to subscribe, but I'm not allowing you to publish. So that's where you go and specify in this policy document saying that I'm allowing you to subscribe, but you cannot publish, so that the client cannot publish. Let's look at a simple policy document. This is a policy document where I'm saying the action is IoT star. So IoT star means I'm saying this client is allowed to do anything. That means they're allowed to connect, they're allowed to subscribe, they're allowed to publish, they're allowed to receive, and they can use any kind of resource. There is no specific resource here. But I can be more specific and I can say this, for this client, I'm allowing the client to connect. And they can use any resource to connect, but then again, that's also is not the best possible way to do it. You should probably define the client, what client is allowed to connect. And I'm saying the client is allowed to publish, and they are allowed to publish for a topic that is called MQTT example. And they can subscribe to the same topic and they can receive. So what is receive? I know that subscribe and publish we talked about, but what is receive? Receive means you are subscribed to a topic, but you can start receiving messages in the topic only if you allow the client to have this policy. So let's look at a sample code and a demo. This is the code which is already, I uploaded it. You can later try it out and play around with it. Let's look at it. So here I'm going to use AWS credentials to connect. Okay. So you see my code, right? So here I'm using a Cognito user pool to connect. So for this, the main thing, this is the AWS console, and the main things you need is a Cognito, IAM, and IoT Core. So what is IAM? IAM is nothing but you're allowing access to that specific user, like what that user can do. And Cognito is where you're going to create that user, and IoT Core is the MQTT broker, kind of. Let's go to this Cognito. Manage user pools. So here I've already created. So in my code, I'm creating a user pool. I'm saying this user is going to connect. So for this user pool, it requires a user pool ID. So let's look at the ID here. So here is my ID for the user pool, which I have given here, and the client ID. I created a client, which is called MQTT client, and the client ID is this. So you can see these are the details of that client. It has a refresh token, access token, ID token expression, and I give the client ID here. I didn't define the client secret, so that's why it's empty. And the region, where is this region? Let me close that. So you could see here, this is the region. So my region is US East 1. I can also set different regions, but this is built on this region. So that's why I have given the region, and it says the user is MQTT user. So you can go here to see what the user is. I created a user, but I'm only going to use this MQTT user. After this, I'm using authentication handler to authenticate the user. So I'm passing the user ID and password I created for this user when I created in the Cognito pool. And then when it is authenticates, I'm getting the token ID. So you can, for AWS credentials, you need the token ID to connect. So if it's success, it gets the token ID, and the AWS IoT manager needs the client ID. So client ID is MQTT client, which I will talk about it a little later when I show the IoT core. And this is my endpoint. So let's look at where to go and find this endpoint. So I'm going to go back to my IoT core, and I created um, um, a thing and a policy. So you can go and see in the settings, after you created, it created me an endpoint. So I'm using that endpoint here, and MQTT client. So where is this MQTT client is coming? So we did talk about we allow certain clients to connect. So you can go to secure and policies. I have a policy document which we said, and in this policy document, I'm saying I'm allowing this person to connect. And you can see it confirms here. So this is the MQTT client. I'm allowing this client to perform connection. Then I have some couple of buttons. So for which you might need to look at my app. So I'm having a button called MQTT Connect and Subscribe. What this does, it takes the token, assigns to a login value, and then I use the Cognito credentials provider, I use the identity pool ID region, and then I connect using all these values set up. So after I connect, this is going to give me all the status callback, which we discussed earlier, that is connecting, connected, reconnecting, and connection lost. And then I have another button called publish. So the publish will, what does publish does? So publish will just get the string from the edit text. So if I write something here, it's going to get that text and publish to the topic. And then the other button is disconnect, and it's going to just go ahead and disconnect. So here we said, what is the topic? Here you can see in my policy document, I'm allowing them to publish to this topic and allowing to subscribe to the MQTT example topic. So if I change this, it will not work. So right now let's look at a working example. So I'm going to go, let's look at the log. So you're going to keep looking here when I do the connect and subscribe. So I'm calling connect, it's saying it's connection. Connection is established, so pretty good, right? So right now it's all looking good. Let's go ahead and test it. So for this, I need my app. Let me put it here. So I'm going to publish, and the topic, we did say the topic is MQTT example. I'm going to publish a topic as hello Android Summit, and I'm publishing. See, it's getting here. So I'm subscribed, and I'm saying whenever you get this message, and you can check the logs too. So I got a callback on this topic MQTT example, and the message I received is Android Summit. What if I go to my edit text and type, how are you today? And I'm publishing to the same topic. So that means the subscribed should get the topic, as well as, let's go and verify here too, if this is also is getting it. MQTT example, and I'm not looking for a JSON, I'm just looking for a string. So I'm subscribed here. So if I publish this, you see it got updated here because it's already listening to the same topic. And also this is a web, it is listening to the same topic as well. So we discussed, right? So if I publish from one place, whichever client is subscribed to the topic will receive that information. Right now we saw the success scenario. Let's see some failures. So I go to the policy, and I said, you're allowed to connect as MQTT client, but now I'm saying I'm not allowing you to connect as MQTT client, but I'm only allowing a person who has MQTT client 1. I'm saving it as new version. Now let me go and run it. Now I'm going to again go and connect, keep looking at these logs here. This is going to fail. It failed. It's kind of weird. It gives you a different kind of error. It doesn't say your client ID is wrong. It just says you're already connected. But since we did talk about the automatic reconnection happening. So here it's automatically reconnecting, and it's trying 0 attempt in 4 seconds. Then you can see in 8 seconds, it will keep incrementing. And until it does 10 attempts, it will keep repeating, and then it will throw you the connection lost message. So let's go back and use the older version. And make this as default. So now again, if I run it, it should work because this is a success one. Let's again go and connect. It connected. Now what if I go back to my overview and change the policy. Again, I said you're allowed to publish to MQTT example. What if I change you're only allowed to publish to MQTT example 1? So here, if I go and say, hello, it received. Did it save? I did say to publish. Let me see if I put here as 1 and save this. Let me go here. Okay. Oh, sorry. Yeah, it crashed because it's saying that the client is disconnected. Oh, sorry, I didn't connect it. Sorry about that. This is also an example. So if you're not connected and if you're trying to publish, it's going to throw you an error. Yeah, because it's throwing an example because your previous subscribed topic is not available. So it's not allowing you to connect. So that's why it's throwing you this error, because the topic which I gave is MQTT example, but the topic here I'm saying is MQTT example 1. So that's why it's not connecting. And also you can do is you can connect a thing, which we talked about, a LifeX or Felix thing. And this is what the shadows I was talking about. You can create shadow states and you can see the desired and reported. So reported is what you get from the actual device, and desired is what you get from the what the client is sending, publishing it to. Let's go back to our slide. And here are some of the reference documents you could use to create your own. And also you can use the example code I gave you to try it out and keep changing the values. Possibly you cannot control the policy document, but I will update the README file. Right now I don't have a README file, but README file, I'll give you the steps how you can go and create your Cognito pool user, and how you can attach the policy to the certificate and use it, and use the same app, just changing the user ID and passwords and the client ID and the topics. Thank you. And there is a session Slack channel available if you want to join and talk about it. Thank you.
All right, awesome. Yeah, thank you. Thank you for that. So I guess at this time we'll be taking questions. So
Okay.
You can drop them in the Zoom channel or in the Slack channel as well. Yeah, we have one question already,
Okay.
and this is from Alexei. How well does it scale in terms of number of topics and number of messages?
Yeah.
I also heard, yeah.
Sorry.
Oh, well, I also heard people had performance issues when using many subscribers to a single topic.
Okay, so you could go to the AWS, and I did give some reference documents. So it allows you like a maximum of 50 topics you can subscribe and publish to. So there is a limit it allows to handle the bandwidth and the performance level. Subscribers subscribe to topics. Since we already said it's only the messages are lightweight. So I don't think like too many subscribers subscribing is going to affect it. But there is a limit it allows, which you can check in their site. And I can get you the exact information if possible, because my platform team worked on all the backend. I tried to just create a simple MQTT broker to understand how it's actually done on the backend. So I don't know all the information. I might be able to answer more on the client side, but I can get you all that information from my platform team. They might have a better understanding of it. But as far as I know, it allows you like 50 topics to at a max to connect.
Hmm. So another question, any advantage over Firebase push notifications?
Firebase push notification, it's basically push notification is different from receiving inside your app, right? So you could use a push notification to see the on the title bar, and I don't know how this would be same as using MQTT. MQTT is more like you connect your network and you're inside your app, you can start receiving messages while you're connected. And also when you're disconnected, if you have the specific quality of service, you can get them back.
All right. Um, is it possible to communicate with IoT things over mediums other than MQTT, such as AWS SNS or perhaps even Firebase?
I'm not sure about Firebase. I did see you can still communicate through HTTP. I'm not sure about SNS, but I can check with my platform team on that. I think it's more on the back end you're asking. Thanks for all these questions. I may not have the right or the correct answers for that. I would definitely check with my platform team on all those information they might have explored, and I can let you know.
Um, so is this limited to AWS? Are there any other nice alternatives to use? Are there any nice alternatives to use MQTT without it? How about hosting your own broker?
You could do that. You can host your own broker. And also there are other MQTT brokers available. We kind of experimented because Comcast already has AWS services we are being using it widely. So we thought to take this route, and it worked out so well for us. And we kind of carried on with it. But there are available, I think like the Mosquito MQTT is available. There are different kinds of MQTT brokers available.
Um, which client, MQTT client, do you recommend if you're not using an AWS MQTT broker?
I would recommend AWS because that's the only one I have tried. But
Mhm.
I want you whoever asked the question to explore and let me know, like if you have compared with other MQTT broker and you felt that this is much easier and simpler than AWS one.
What are the different use cases for MQTT? Is it only more favorable for communications with IoT devices?
It's more on, as I told earlier, like based on your network reliability and application, not just specific to your IoT devices. I did show you a simple message, right? Like my app was just receiving simple messages. So you can use that as well to communicate between the clients. It doesn't have to be IoT devices, but more useful when you come into the IoT world, especially when you're supposed to receive your light status. For example, your light status should be on. You can use a quality of service one. So that means if you're in a train for a short period of time, your network is down, when you come back, there is a high possibility you can get it. But if you're using HTTP or other ways, there is no guarantee that you're going to receive that information. It's going to still show you the old state unless you go ahead and refresh.
All right. Thank you. Um, I, I don't see any more questions coming in. So yeah, so
Yeah.
I think that's all. Yeah.
Okay. Thank you everyone for coming to this. Sorry if I couldn't give you the exact answers you were looking for, but definitely I'll be available there, and I can check with my platform team as it's more related to the backend you were looking for. I can get answers for you there and give it to you. Thank you.
All right. Thank you. Um,
Should I just go ahead and